Bonjour! Hello and welcome everyone to our second Mission Space virtual excursion, Cryptic Chemistry. My name is Ryan and this is my friend Laura.
And we're from the SciTech Discovery Centre. We're broadcasting to you from Boorloo, Perth.
And as such, we would like to respectfully acknowledge the Whadjuk people of the Noongar Nation, traditional owners of the land that we're broadcasting from today.
We'd also like to acknowledge the Aboriginal and Torres Strait Islander peoples from all across Australia and pay our respects to their elders past and present. We'd like to acknowledge them as the first scientists of Australia and value their contributions as engineers, innovators and problem solvers.
You're joining us from all around Australia today as well, which is super exciting. We're going to bring you briefly away from your classroom lessons through the screen right here to SciTech.
And we have a map where we've put all of you as a little pinpoint. Can you find yourself in the map somewhere?
Yeah, it's fantastic. There's so many of you out there. So we've got a few people behind the scenes helping us out today. They're going to be operating the cameras, changing our special effects, and activating the live chat, okay? So if you can get involved in the live chat, please do so.
We've got so much to share with you today. We have science demonstrations, planetarium tours, expert interviews, and more. And we're hoping we can show you how what you're learning at home and at school can help you decode the universe and launch you among the stars.
Yeah, so chemistry is our daily topic today, so it's another interesting one. Chemistry, we're looking at how things heat up, cool down, mix together, react, and if we apply that to space, there's things like, I don't know, rocket fuel or what things are made out of. All these very interesting questions, but people still have a lot to learn.
Yeah, and let's kick everything off with something fun. Roll the tape.
We've driven our SciTech truck out to the Gravity Discovery Centre in beautiful Gingin, Western Australia. We already know lots about chemistry because humans have done some really cool experiments. There are lots of chemistry challenges in space, like extreme temperatures or high-impact collisions. We've got some random groceries, tennis balls, and this guy. What do you think will happen when we dip them in liquid nitrogen and drop them 45 metres?
3, 2, 1.
Whoa, that was awesome!
Yeah, it was amazing. Well, yesterday we were looking at meteorites. Today we're looking at what things are made out of, such as the International Space Station.
Yeah, I've heard the International Space Station has walls made out of aluminium. But I was wondering why they were made out of aluminium.
It's a good question. Science is a process of asking questions, making predictions, and doing experiments. So take a moment. Why do you think the walls of the International Space Station are made out of aluminium? Is it important? Any ideas?
I don't know. Seems pretty weak to me.
Well, this next video might have some of the answers. Check it out.
Let's put an aluminium pipe through the same test.
3, 2, 1.
Not a scratch. Aluminium is used in building the International Space Station because it is lightweight, strong, and relatively cheap. A bit different to our rubber chicken.
Whoa, I guess that's a great thing about science. You can keep learning more all the time.
Yeah, and scientists do. They do ask questions, make predictions, do experiments to discover more, and then when they can share it with us, we can all learn too. And that's what we've got for you next. If you missed yesterday, we had an interview with Katherine Pegg, Australia's very own astronaut. Super exciting. We've got some more of that video to share with you today, so enjoy. Can anyone be an astronaut?
Well, to be an astronaut means you have to fit a certain type of criteria, but those criteria do change over time. Astronauts many decades ago were more test pilots and more individualistic personalities. Now we're on the space station, it's about teamwork and being an all-rounder in many topics. In the future, who's to say what profile will be looked for? So even if you don't fit the profile today and you want to be an astronaut, you can absolutely strive for it because things change. In the astronaut selection I went through, they recruited a person with one leg, right? And that had never been done before. So these criteria do change over time. But to be an astronaut today, in the selection I went through, what was the most important thing is that you have a first career in a STEM field. So you can't finish school and immediately be an astronaut. There's no university program or graduate job that is being an astronaut. You need to spend a number of years doing something else first. So my advice would be to pick something in a STEM field that you would like as a career anyway. So you can be a scientist of almost any kind. You can be an engineer of almost any kind. You can be a medical doctor. You can be a pilot on almost any kind of aircraft. But in addition to that, and to achieve that, you need to work well at school, because if you do well at school, more doors open for you. You also need to have other skills. So you need what's called an expeditionary mindset, which means you work well with people under pressure, particularly in the field environment. So activities like sports or scouts or the military, cadets or camping, they're really good bases for teaching you how you can behave better in an expeditionary environment. So you do that by pushing yourself out of your comfort zone, seeing how you react, and then working on that and actively improving your performance. You also should have operational skills, which means hands-on skills where there may be a risk to someone's safety or life. Space is also an international endeavour. So knowing how to work with people from different backgrounds and different cultures, finding something that you share a passion for and getting along, that's a fantastic basis as well. So anyone can strive to be an astronaut. The criteria change. Pick something you love anyway and you set yourself up for the best chance possible.
What subjects will I have to study if I want to be an astronaut?
So if you want to be an astronaut, you need a STEM career first. So it's important to do topics like maths. But in terms of the sciences, you can pick any of the sciences. So physics, chemistry, biology could all be topics, and other kinds of sciences too. Some schools offer engineering and other technical subjects. They're also relevant. But don't forget to pursue broad topics that interest you as well. For me, when I was at high school in my final years, I studied advanced English, advanced mathematics and extension mathematics, physics, chemistry, and economics. And in year 11, I also had geography as well. And I would have loved more subjects. I think in any topic, you can find something that's interesting, that can spark your curiosity, but pick the ones that you can find joy in. To put effort in is something that you can love to do and you'll do better.
Did you do chemistry at school? And if so, what was your favourite part about it?
Yeah, I did study chemistry at school actually, all the way to year 12, and gosh, I like so much about it. One thing that I remember liking later in high school was all the experiments, so getting to do what was called titrations, which is where you've got to get things just right to get a chemical reaction. I really enjoyed learning about combustion, and my thesis for engineering was on microcombustion, so understanding how we can have tiny, tiny flames, almost like engines on a chip. So that knowledge was very interesting for me. Also for rocket propulsion and satellite propulsion, it was a really, really important basis. Yeah, the periodic table is an amazing tool and an amazing categorization, and we use it in all forms of science. I loved understanding about how some of those materials, those elements, had to be created in the lab because they're not stable enough to exist for very long. And I remember learning that almost every one of those elements is made in the insides of stars, meaning we're all stardust, right? And just thinking back through the ancient times of what the universe was doing and how we all came to be here, that's really awe-inspiring stuff. And the periodic table is an amazing reminder of that.
Oh, I just love Katherine. She's got so much amazing stuff to share with us.
Yeah, she's amazing to talk to. And in this particular part of the interview, I really like talking about how anyone could be an astronaut. That was really empowering for me. Also like talking about how you should study STEM subjects, you know, and how that helps. So science, technology, engineering, maths. And the stuff that you learn at school can be applied just about anywhere, including in space.
Yeah, I love what she was saying about those experiments, the titrations. I reckon lots of our viewers at home or at school might have done their own science experiments.
Ooh, what would be a favourite science experiment of yours? Or maybe of yours? Have a think. let's put that question in the chat for later. Now, if you do stay tuned until the very end of the session, we've got another transmission from Dottie Metcalf-Lindenberger, a retired NASA astronaut who's got some amazing stories to share with you all. So that'll be a bit later on in the session.
Oh, we're being interrupted again.
Again.
Oh.
We'll go fix this.
Hello again. I told you I'd be back, and if you don't know who I am, my name is Zog.
Oh, Zog, I thought we defeated you yesterday.
Well, you did, but you know the way I roll. You need to answer me these questions 3.
Okay, everyone, turn your brains on again.
Well, easy one straight off the top. Plastic, wood, and even air are good examples of what?
Oh, I'm thinking either conductor or insulator. If you think it's a conductor, put your hands on your head. If you think it's an insulator, put your hands on your hips. Oh, okay, I've got the answer. I can see you all. Okay, it would be insulators.
Oh, I told you that was easy. I told you that was easy. But question 2. Question 2. Which of these is not a property of all metals? Conductive or magnetic?
Oh, if you think it's conductive, put your hands out like this in front of you. If you think it's magnetic, put your hands behind your back. Oh, okay, I can see. It would be magnetic.
Oh, yes, you're right. Not all metals are magnetic. In fact, there's only 3 normal ones that are. Iron, nickel, and cobalt. Remember that.
Okay.
Well, I saved the hardest question till last. You ready? Well, there's different important components in an electrical circuit, okay? Which of them controls flow by opening and closing a circuit?
Oh, I think it would have to be either a switch or a conductor. If you think it's a switch, put your hands out like this. If you think it's a conductor, put your hands on your head. Oh, okay, I see the answer. It would be a switch.
Oh! I need to think up some new questions.
Oh, great job, everyone! Oh, those are some complex chemical questions for us today.
Yeah, now I think I might need to read up on a bit more of my chemistry knowledge just in case Zog comes back.
Yeah. Well, one of those questions was about the chemicals in rocket fuel. Oh, but I've forgotten what chemical it was.
Yeah, well, Evan actually has prepared another science lab experiment to share with you all today, so perhaps he might have the answers. Hey, Evan.
Hello friends and fans, welcome to the Science Theatre. My name is Evan and today I decided we'd keep it simple. Because sometimes we look at the realities of space travel and it can seem really complicated and tricky, but hey, it's not rocket science. Oh, I guess it is rocket science. Well, today we're doing some rocket science. Now when you think about it, when you really boil it down, rocket science isn't that complicated. You've got an object that you're trying to launch somewhere and a force that's making it go up. See? That wasn't really much of a rocket. Most rockets use some kind of form of pressurized air, like this. In this case, we're storing the pressurized air inside this elasticy part of the balloon, and when I let it go, the air is going to come out one way and the balloon is going to fly off, hopefully, in the other direction. Very, very hard to control. Now, at really small scales of rockets, we can work with some quite manageable energy sources to make that high pressure gas inside a rocket and get some really, really nice control and reactions over our rockets. So what I've got here is a rocket with a bunch of vinegar in it and a base with a whole lot of baking soda in it, and well, I don't know if you've ever mixed the two of them together, but we'll get a lot of bubbles. Those bubbles are gas, which is going to be kept trapped inside this, build up to nice high pressure, and when it builds up to enough pressure, the rocket will launch itself just like that. However, when we start getting to larger scale rockets, we need to use bigger and better forms of ignition. So we can use solid fuel. What I have here is nitrocellulose. Now, solid fuel rockets are relatively common. A lot of hobby rockets use solid fuel, mostly use like powder rather than nitrocellulose, but we're gonna give this a go and see how it works. Turns out, not great. You see, even though it burns really, really hot, creates a lot of energy, there's a lot of that high pressure combusted gas inside the rocket, the nitrocellulose burns really, really fast, we don't get a nice controlled thrust. More importantly, we didn't have a nice good seal over the end of our rocket to control the direction that we wanted it to go. Rocket science is getting trickier and trickier every day. Now, I have heard that a lot of rockets use hydrogen as fuel, specifically liquid hydrogen. Now, I don't have liquid hydrogen, but I do have hydrogen gas, which should be just as good, right? Now, to ignite our hydrogen, we also need oxygen. There's plenty of oxygen in the air around us. It's about 20% oxygen. I'm breathing okay. There's tons of oxygen in here. So we've got hydrogen, we've got oxygen, and we need to find a way to make this gas go under extremely high pressure. And igniting it on fire seems like a great way to do that. Let's see how our hydrogen burns in 3, 2, 1. See, rocket science isn't hard. All I need to do is get about 1,000,000 times that volume of hydrogen, about half that volume of oxygen, stored as a liquid in really, really strong containers so that when it ignites, all the force of that thrust is headed downwards, which launches our rocket up at 28,000 kilometers per hour. You know, rocket science is pretty tricky. I might stick to brain surgery. That's all from me. Back to you in the studio.
Oh, wow. So some chemical reactions have more energy to release.
Yeah, I really like seeing the balloon experiment. It went boom because of all the hydrogen inside it. That was pretty cool.
Yeah, wow. I guess all of these chemical experiments that we do are really important for space as well.
Yeah, but you could do one of these experiments that Evan did at home or at school as well. If you have a little bit of bicarb soda or some vinegar, you can mix that up together and see what happens. Try putting it inside a bottle with a balloon over the top. What do you think would happen to our balloon if you did that? Any ideas?
Oh, I don't know.
It's a good question. It'll probably inflate, yeah? Think you can figure out how to make it burst? I'll leave that with you to experiment.
We do have even more amazing science to do. In fact, we have another expert interview to get to now.
Yeah, Stephen Mogak from UWA is going to talk about the chemistry that they do and how we can use that to learn more about some other places in our solar system. So I'll be back.
Bye.
Whoa! Hi, Stephen.
Hello.
Thanks for joining me.
Oh, it's a pleasure.
Let's begin. So, Stephen, have you always been interested in space rocks?
I think so. I've always been fascinated by crystals, which is what a lot of space rocks are made up of. But I guess my passion for it in terms of research really started about 1.5 years ago properly. So I'm a crystallographer, it's what I do, right? I basically fire X-rays and neutrons at crystals, and I guess we'll get to why that would be a good idea in the first place.
So how can you do experiments about space if you've never been to space?
I'm petrified of roller coasters, so I'm not sure going to space is a good idea for me. But one of the things we can do in the lab is quite safely recreate those conditions. We can cool materials down using a cold flow of liquid nitrogen, which we've got behind you. We can actually really carefully control the temperature from ambient temperature. Well, ambient on this planet temperature, which is about room temperature, about 22 degrees, I guess, maybe a bit higher in Perth, depending on the time of year. And then we can cool right the way down to minus 181 degrees, really carefully, and look to see what kind of solid materials form. So we can actually crystallize things inside the diamond anvil cell. Now, in order to be able to see where the molecules are in my crystal, I actually need to fire X-rays at my crystal.
Did you say that this has something to do with Titan? And
yes,
Titan
so we're obsessed with recreating the conditions on Titan, and so we use instruments like this one behind me. So this is a diffractometer. It allows us to do two things. It allows us to actually discover where molecules are in a crystal, and it also allows us to cool crystals down to the kinds of conditions that you get on Titan. So things that are gases here are liquids there, things that are liquids here are solids there. So Titan's really unusual. It's the only place in our solar system other than Earth that has an active weather system. Now, if I went digging in the ground in WA, right, I discover minerals, right? We love digging, right? The mining industry is a big thing. But the mineralogy on Titan, like what's actually the rock formations and the lakes that are there, are actually composed of molecules, molecular materials. So they get all these really cool reactions occurring in the atmosphere that fall onto the surface. So we discover things like benzene, for example, which is a 6-membered ring carbon molecule, which is a liquid here, but it's a solid on Titan. So what we want to do is we want to try and look at what kind of rock formations can form, what the mineralogy is on the surface. Now, I can't jump on a plane and go to Titan, so what we do is we recreate those conditions.
Fantastic. Can anyone do this kind of science?
Absolutely, right? I mean, I'm always a big believer that if you've got a passion for it, and it's what's between your lugs, right? What's in your brain, right? If you've got a passion and you want to do science, of course you can. I mean, there's absolutely no reason why you couldn't get involved in the kind of crystallographic research that we're doing here. I mean, it's quite applicable.
Can you think of any fun activities that students can do at home or at school to start learning about space crystals?
Absolutely, right? Next time you're at home, look at how things pack. So if you've got, at Christmas time, you've got Christmas wrapping paper. And in fact, if you look at Christmas wrapping paper, pick a point in that wrapping paper that repeats, and you can just draw like a round dot on it and join the dots together and look at the contents of that sort of square shape that you get. And what you should discover is that that square shape actually has the exact same contents on the wallpaper. Now, like when you look at tiling in a bathroom, right? Like you'll get square tiles and you'll get rectangular tiles, but you'll never get octagonal shaped tiles. You don't get eight-sided tile shapes. In fact, the reason for that is because you need square ones in between, right? So you need 2 different types of tiles. So there's actually only certain types of packing arrangements that are allowed, and they're actually all around us, right? They're on the floors, they're in artwork. If you've seen Escher sketches before, for example, if you look at the labyrinth, that kind of, inspiration, right? Like that kind of symmetry, nature uses it all the time, and crystals use it in particular.
Fantastic. So it's like looking for patterns.
Looking for patterns,
Help you understand the universe.
And so you think there might be an infinite number of ways to stack things in a solid, right? In a crystalline solid. But in fact, there isn't. There's 230 different ways. Right?
Wow.
Now, most molecules use 1 of 4. So there's ones that are really common, but actually you see those kind of stacking arrangements in nature all the time.
Thanks, Stephen. It was great talking to you.
Thank you, Ryan.
Catch you later.
Whoa!
We're back.
Yeah, so Stephen is a chemist in Perth, but he's doing stuff all about space.
Yeah, so Stephen's been replicating the conditions of Titan, Jupiter's moon, which is mind-boggling. I bet it would be very strange on Titan compared to here on Earth. Everything would look very different.
Zog is back again!
Every time.
Hello again, everyone. I told you I'd be back. You can't get rid of me that easy. No one can. Oh,
Hello,
you
Zog.
Oh, well, you know the deal. Answer me these questions. 3. Are you ready?
Here we go, everyone.
True or false? Light from the sun reaches the Earth in under 5 minutes.
Oh, if you think it's true, put your hands on your head. If you think it's false, put your hands on your stomach. Oh, okay, I see the answer. That would be false.
Oh, how did you even know that?
Good job, everyone.
It is a really good stopwatch. I've got another question. What technology do humans use to convert the sun's energy into electricity?
I think that would either be microwaves or solar panels. If you think it's microwaves, make a big microwave above your head. If you think it's a solar panel, make a solar panel in front of you like this. Oh, okay, I've got the answer. It would be a solar panel.
Oh, you are correct. You really are a bunch of smarty pants, aren't you? Well, question number 3. You ready? No one ever knows this one. What happens when a black hole eats a star? I bet none of you have even seen a black hole. A. Does the light from the star immediately disappear? Or B. The black hole burps a little bit of the star back out?
If you think the light immediately disappears, cover your eyes like this. If you think the black hole burps a little bit out, put your hands underneath your chin like this. Okay, I can see. Oh, you guys are really smart. Oh, the answer is the black hole burps a little bit out.
Whoa! Ooh, how dare you? I'll be back. I will be back.
Oh, good job, everyone. Man, I hope Zog's all right. Oh, we did it.
We did it. Yep. You think they'll be back later?
Probably.
Now, I've been learning lots, though, from all these quizzings and professionals, so at least we're still having a good time.
Yeah, and one of those questions about comets and how the tail is made by the rock sublimating, that was really interesting because the process of sublimation when a solid goes straight into a gas, that's actually a process that's being used here in Australia to design satellite propulsion systems.
Oh, I heard about this. So Boswell Tech is creating a cold gas propulsion system, which they've tested on CubeSats and Skycrafts, making our satellites more efficient, which is pretty awesome. But guess what the solid fuel they're using is?
Oh, I don't know, what is it?
Mothballs.
Mothballs? What? I better tell my grandma she's got rocket fuel in her cupboards.
Talking about satellites and rocket fuel and comets is making me think of planetariums, a place where I love to learn about space. So we've actually got Leon, once again, has a very special planetarium experience to share with you all.
Hello everybody, welcome to the SciTech Planetarium. My name is Leon, and today we are exploring the mystery of cryptic chemistry. Here is our Earth. Scientists know that life on Earth started in the oceans. About 70% of Earth's surface is covered with oceans. We have some ice at the North Pole and the South Pole, but most of the water on Earth is liquid. Scientists think liquid water is essential for life to evolve. But the question is, where did all this water come from? One big idea that scientists have is that the water on Earth might have come from comets. You've probably heard of Halley's Comet. It's the most famous comet ever discovered, but there's millions more of them. Comets are made of rock and ice. As they orbit the sun, sometimes they get close enough for that ice to melt and boil away into space. And this gives the comet a big, glowing, cloudy appearance. As scientists, we wanted to know if the water we find in comets is the same as the water we find on Earth. So we sent a spaceship called Rosetta to visit a comet called Churyumov-Gerasimenko. That's quite a hard name to pronounce, so most scientists call it 67P instead. The Rosetta spacecraft studied the water boiling off Comet 67P. If the water from the comet looked the same as the water we find on Earth, then we would know that the water on Earth comes from comets. If the water from the comet looked different to the water on Earth, then we would know that the oceans on Earth didn't get their water from comets. So, what did Rosetta discover? Well, some of the water from the comet looked exactly like the water on Earth, but some of it looked very different. A special type of water called heavy water, which is very rare to find here on Earth. We'll need to visit more comets to find out the answer to where Earth's oceans came from. Scientists studying comets have also found complex organic molecules like amino acids. Amino acids are what your body uses to build your DNA. Without DNA, you wouldn't exist. When life first formed on Earth, did the amino acids to make DNA come from comets? We don't know the answer to that just yet. More science is needed. This is Saturn, and this is a moon of Saturn called Enceladus. It's covered in ice. Scientists built a spaceship called Cassini and flew it to Saturn. Cassini discovered that Enceladus has volcanoes, but not lava volcanoes like here on Earth, water volcanoes. On Enceladus, water erupts from the ground in great geysers. This tells us that Enceladus has an underground ocean of liquid water hidden beneath its icy surface, just waiting to erupt. Scientists flew the Cassini spacecraft through the eruptions of the water volcanoes to see what they were made of. And they discovered complex molecules like carbon monoxide, methane, propane, and ammonia. These are chemicals that we find on Earth all the time. Does this mean Enceladus has aliens living under the icy surface? Well, we can't say for sure. We can't say no either. Chemistry unlocks the secret workings of our solar system and beyond. And I can't wait to see what we discover next in the great mystery of cosmic cryptic chemistry.
Oh, thanks, Leon. That was great. I love the planetarium.
Yeah, I think it's a wonderful place to learn. You can also do some of your own learning by, reading books, searching online, watching documentaries. I personally recommend someone like Brian Cox or Neil deGrasse Tyson. They're great to learn from because there's so much more we can discover.
Yeah, and we've got even more to discover with our next expert interview. We have Lauren Springer from the Australian Space Agency. Bye.
Hi Lauren, how are you?
Good, thank you. How are you?
Good, thank you. Thanks for joining our interview.
No worries. Happy to be here.
Have you always wanted to work in space science?
No. So originally I wanted to be an author. And I loved writing and writing stories and poems. But the thing that really got me into space and space science was I watched a documentary one day about how all humans on Earth, everything that we see all around us came from a dying star, the core of a dying star. And I thought that was just really beautiful. So that made me want to discover more about space science. And I went into astronomy and started learning more about that kind of thing, and it really just took off from there, and I haven't looked back ever since.
Fantastic. Is there anyone in particular who inspired you?
Yes, so Brian Cox is one of my favourites. He's from the UK, the United Kingdom and England, and he does a lot of documentaries, but also Neil deGrasse Tyson from the US is also one of my people that I look up to.
And I bet there's lots of online resources and books that they've done too that we can...
Definitely.
Yeah,
definitely. They have a lot of books, they do a lot of TV shows, sometimes they come touring around Australia. So if you get the chance to go to some of these things, it's a really great way to meet your heroes and to get you more involved in space and space science.
So what sort of things do you do on a normal day at work?
No 2 days look the same, so I do something very different every day. But for example, I can be visiting sites all over Australia to visit researchers and see what they're doing. A few other things I do as well is I do a lot of work with international space agencies, writing papers and seeing how we can collaborate more effectively in a more global manner to really make sure that everyone has access to space and that space is really for everyone. It's not just for the scientists, but it's also for the engineers, even the lawyers. We definitely need good space lawyers in the future. But yeah, so that's just some of the few things that I work on and also a few research projects as well.
What is a super cool research project that you've worked on?
Yeah, so I was lucky enough when I was doing my undergraduate degree at university, at Curtin University actually, looking at radio astronomy and detecting the really, really faint signals from the very early stages of the universe. And I got to look for really faint radio signals to see what the early universe looks like, and also do a little bit of alien hunting and planet hunting in there as well.
Fantastic.
So, yeah.
Did you find any?
No, not yet, but it was World UFO Day yesterday, so we're still holding out, but hopefully eventually we might find something.
Where do you think Australia's space industry will be in 5 years' time?
Yeah, that's a really good question. I think we've come a long way since the space agency started. So the space agency here in Australia is 7 years old now. In the next 5 years, hopefully we can see some of our own Australian people going up into space. We have our astronaut candidate, Katherine Pegg, who's completed her training. So it'd be great to see her go up on a space flight and a space mission.
So what was your journey like moving from Perth to work here in Adelaide?
It is hard sometimes traveling and leaving your family, but the good thing is that you can find new friends and you can find new interests, and there's always people wherever you go that are willing to talk about space.
Thanks for the interview, Lauren.
No worries, thank you for having me.
Great. So that was great to speak to Lauren, and it's really interesting to talk about how people working in space don't exclusively work on one subject, okay? They borrow from lots of different areas of interest, and it's really important that we study lots of those different areas too.
Yeah, absolutely. I reckon some of our students watching from home or from school probably know a lot about all different areas of science, and they might even know a little bit more about the cryptic chemistry that we're talking about here on Earth.
Yeah, so maybe you've looked at how mixing things together create reactions, or some of you smarty pantsers might already know perhaps what stars are made out of.
Ooh. Dog's back again.
At least we know how to deal with this.
I told you you wouldn't get rid of me. I'm back again.
Zog, you're back again?
Yes, well, my friends wouldn't listen to me asking questions, but I know right here I have a captive audience.
Right.
Well, you know the deal. 3 questions, me 3. Here we go. You ready? The gravitational force felt on the moon is what fraction of the force felt on Earth?
I think it's either 1/2 or 1/6. If you think it's 1/2, put one arm up like this. If you think it's 1/6, put your hands on your hips. Oh, okay, great answers, guys. The answer to that question is 1/6.
Oh!
We did it, guys.
I've got a good one. Okay, if I were to drop a spanner and a ping pong ball on the moon, which one would hit the ground first? The spanner or the ping pong ball?
Ooh, if you think it's the spanner, put your arms out like this. If you think it's a ping pong ball, make a little ping pong ball with your hands. Oh, okay. Wait. Oh, yes, you're right. That was a trick question, Zog. They both hit at the same time.
Oh, I was sure that one would get you. Oh, no. Okay, well, last question. 3 questions, I said. What 2 motions do all planets have? Are you ready? Mm-hmm. Orbit and spin, or rock and roll?
Oh, good question. If you think it's orbit and spin, do a spin. If you think it's rock and roll, do a little dance on the spot. Okay, yep, great answers, everyone. The correct answer is orbit and spin.
Oh, no one will listen to me anymore.
We did it, guys. We defeated Zog. Oh, those were some tricky questions, but I saw some people playing along at home got all the answers correct. But I reckon Zog will be back again tomorrow.
Probably back tomorrow, but let's recap on what we looked at today. We had another part of our Katherine interview to share with you all. I love learning from Katherine. We spoke to Stephen and Lauren about some of the work that they're doing around space and space research, which is very exciting. Plus, we looked at comets and what comets are made out of in the Planetarium with Leon. And we got to do some more experimenting with Evan as well. So there's so much that we've been covering today.
Yep. And we were challenged by Zog the alien.
Of course, Zog was back again. I wonder if they'll be back tomorrow. But the main takeaway I'll take away from all of this is that science and space is for everyone, okay? So curious minds of all kinds can follow their passion and find a role in the space industry, not just astronauts. Build on what you're learning at school and you can make discoveries in space that benefit life on Earth as well.
Thanks so much for joining us today. I hope you've had a bit of fun and we hope you can join us again tomorrow.
Before we say our final goodbyes, we've got one final transmission from Dottie Metcalf-Lindenberg all the way from the USA. Retired NASA astronaut, has some amazing stories to share with you. So I'm going to put that transmission on right now.
Enjoy. Thanks for joining us and we'll see you tomorrow. Bye.
Hello, hi, I'm Dottie Metcalf-Lindenberger. I'm a retired NASA astronaut. I flew to space before you were born. I flew in April of 2010 on a space shuttle to the International Space Station that continues to grow and do amazing things. Anyone can learn about space, and I think that's why I love it so much, is that I was a former high school teacher, and my students were learning about space, and they had such an interesting question about, like, how do you go to the bathroom in space? And that question is what got me looking it up. And guess what? Online, NASA had an answer. So yes, anyone can learn about space and should, because there's lots of good questions to solve out there. you should study lots of different things. Things that help you be a good reader and a learner, things that help you be strong in math, in science, but also study things that you're excited about, because we need all different types of people helping us get ready for space. Space isn't just about governments going anymore. It's also about commercial companies. It's about people thinking creatively. So we need all sorts of people working for us in space. Maybe you are an artist or someone that wants to be a lawyer. Maybe you want to do science or be a geologist like me. Or maybe you're an engineer, a mathematician. So many different jobs and opportunities. But you do need to study in school. And so that's what I really want to emphasize, is that all astronauts have worked hard to get where they're at, and all people working in the space industry have studied hard too. So go study lots of different things, do your best, be curious, and don't mind the challenges. They're worth it. I hope that you are always curious about space, but no matter what, I hope that you work hard in your classes and learn lots about Earth and space, because I hope I've showed you today that they're really together. Like, we are on a spaceship, and that spaceship is our Earth, and that we have to take care of it. And by understanding Earth, we can understand more about space, and then space can also help us understand about Earth. So be curious about it, keep working hard and challenge yourself in your classrooms, and have the courage to go after your big dreams like I did with being an astronaut.